NASA headquarters? Is that in D.C.?
There's NASA's all over the place.
That's
but
what I
yeah,
thought.
the headquarters is right in D.C.
Okay.
Like within walking distance of the Capitol building.
Oh, okay.
And then there's about a dozen centers around the country that are really where a lot of the action happens. So the most famous one is like Houston and Cape Canaveral. But then there's a really big life sciences group in Maryland. We're in New York City, basically with NASA. There are a bunch of physicists at Columbia University. And they're like, yeah, come on down to DC. And they said, no, we're going to stay here. Yeah. So it ends up being a little NASA center. I've been there for 15 years now. I went as a postdoc and then they hired me on.
All right. So welcome to Science-Based Choices for Climate Action. The session that's about to start is entitled Climate Change Evidence and Causes. We're delighted to have you here with us, whether you're in person or whether you're watching virtually. We've had 3,000 people register for this symposium. I don't think they're all online right now with us, but it's a very large international audience here with us. I think we've got Cumberland Valley High School. Noise? Okay. Ursinus College? Gettysburg? Westchester, Franklin and Marshall. Who did I leave out? Dickinson? Okay. All right, so thank you all for joining us. So during this session, you'll have an opportunity to ask questions. If you're here in the in-person audience, raise your hand. Somebody will bring you a microphone. If you're watching the live stream, you can type questions into the chat. We'll be watching for those, and we'll feed those to the moderator when we get to the Q&A part of this. When you ask a question, state it very succinctly, concisely. We're more likely to use it if you're in the live stream audience, if you make it very concise. Some things just to note, if we do have an emergency, there's an exit off to my left that way. There's an exit up at the top right here as well. Is that an exit off to the top left too? Yes. And then there's a handicapped accessible exit back behind me, behind the curtains. We will make sure the curtains are moved out of your way if you need to go that way. So with that, I'll turn it over to our moderator, Kristin.
Wonderful. Thank you. Welcome, everyone. So glad to have you back with us this afternoon. My name is Dr. Kristin Strock. I'm an associate professor of environmental science and chair of the environmental studies department here at Dickinson College. Welcome to our panel on evidence and causes of climate change. I'm going to provide very brief introductions for our panel members today. I encourage you to refer to their biographies in the symposium materials if you're looking for a full account of their impressive work advancing our understanding of climate change. I'm going to begin by introducing Dr. Linda Mearns, senior scientist at the National Center for Atmospheric Research and IPCC Working Group 1 author. She's also a review editor in Working Group 2, and she is the head of the Regional Integrated Sciences Collective within the Research Applications Laboratory. I'm going to also introduce Dr. Alex Ruane, research physical scientist at the NASA Goddard Institute for Space Studies and IPCC Working Group 1 author. He is also co-director of the GISS, do you say GISS?
Yes, yeah.
Yes. GISS Climate Impacts Group and an adjunct research scientist at the Columbia University Center for Climate Systems Research in New York City. Dr. Ruane is also on the core writing team for the IPCC synthesis report and focuses on food system impacts of climate change in his own research. And lastly, we have Dr. Jesse Abrams, also behind me here, research fellow at the Global Systems Institute at the University of Exeter and member of the Earth Commission, convened by Future Earth and the Global Commons Alliance. Dr. Abrams is an expert in systems thinking and is a co-author on a recent paper updating the risk of crossing tipping points in the Earth system. I'm not going to say most importantly because that's very important work. However, notably, Dr. Abrams is also a Dickinson alumnus. Very happy to have you back. Please join me in welcoming our speakers today. Wonderful. So although this session is entitled Evidence and Causes, we have less than 1 hour. And so that's not nearly enough time to cover all of the evidence that human-caused climate change is impacting all corners of our Earth. But the previous sessions this morning detailed this monumental effort that goes into preparing IPCC reports. And so to kick off this session, I've asked each of our speakers to walk us through a key piece of evidence that describes the human-caused changes in our climate, how this science came to be, and the implications of this science. Dr. Mearns, can you kick us off?
I believe I can, especially if I can successfully share my screen.
Perfect.
And immediately move to the major slide here. So first of all, before I do that, just a little bit more about me. I'm a lead author in the Atlas chapter of Working Group 1. And I'll say a little bit more about that. I've also been involved in all the IPCC reports from 1995 moving forward. So all of them except the very first. So first of all, I want to give you a perspective going through the different working groups, through the different reports starting in 1990 about our increasing confidence in the science. So I'm just going to talk about the observed increase in temperatures that have been observed throughout the world for a long time. When we start with the IPCC 1990 report, it's very interesting because it doesn't really say that humans are responsible for this. It says the observed increase in temperatures could be largely due to natural variability. Alternatively, this variability and other man-made factors could have offset a still larger man-made greenhouse warming. So it's kind of sitting on the fence. They're really not making a definitive statement about this. But come 1995, in that report, things change quite radically. And the statement is made, the balance of evidence suggests a discernible human influence on global climate. And this statement had a very big effect on climate science in general and policy throughout the world in terms of, gee, we really need to pay attention to this. IPCC 2001, there is new and stronger evidence that most of the warming observed over the last 50 years is due to human activities. IPCC 2007, we now get into the more quantitative uncertainty language of the IPCC. Most of the observed increase in global temperatures since the mid-20th century is very likely due to the observed increase in greenhouse gas concentrations. IPCC 2013, we go to extremely likely, and then in 2021, it is indisputable that human activities are causing climate change. So you can see very clearly this increasing certainty about one of the key aspects of climate change, that we are responsible for global warming. Another point I want to bring up going to the current report, and Alex Ruane mentioned this briefly in the earlier panel, and that is the issue of regional climate change, that getting to the regional scale is becoming more important. And in the Working Group 1 report, there's also an interactive atlas, and I urge you to check this out. It's actually an opportunity for you to create graphics of your own. And there are different levels of information. There's regional information, sort of simple climate information, then more advanced regional synthesis, which I think Alex will be talking more about, and then the documentation. And this just further illustrates what's in there. We're looking at model projections both from the prior IPCC set, the CMIP 5, the current set, the CMIP 6, and then regional results from regional climate models that give you more detail, and that's the Cordex set. So I'm not going to read through all of this, but there's an amazing number of variables available that you can look at and learn more about on your own. And I'm going to stop sharing at this point.
Wonderful.
There we go. It worked. How thrilling. Well, you know.
Thank you very much, Linda.
Stop share. There. Okay. I'm gone. I mean, I'm here. The report is not. Sorry, one other thing I wanted to say is two things since I'm not really there. I just wanted to really thank Neil Leary for inviting me. And I noticed, Neil, that we've both gotten grayer, which is not a big surprise. But luckily, there are people that still have color in their hair, like Alex, who can move forward on that. I also just want to call out my colleague, Deborah Roberts, and I'm particularly sorry I'm not there to see her because Boulder and South Africa don't exactly intermingle a lot except in the IPCC context. So I'm particularly sorry, Deborah, not to be in person with you.
As soon as I walked in, Deborah asked about you and wanted to know if you were here as well. So I think the feeling's mutual for sure.
I was so close to being there,
yes,
but a family matter came up and I just had to cancel.
Let's pull Alex's slides up. We appreciate you joining remotely, Linda.
All right, so while my slides come up, I'm going to take some of the key figures that came out of the summary for policymakers from Working Group 1 to talk you through that. And I might actually request, with their forgiveness or hopefully permission, maybe if we could minimize the video of the other panelists, then we could see the whole thing. Okay, thank you.
What? What?
Sorry, Linda. All right.
Alex, I'm barely there at all, and now you want to minimize me? Jeez.
All right. So one of the big challenges as we were putting together the evidence, you know, the climate change, physical science, we've been pushing more and more to make this not just an academic exercise of interesting physics, but to make the climate information useful. So a drive in the most recent assessment report was to try to figure out what are the precise climate conditions that different aspects of nature and society respond to. So we developed a term called climatic impact drivers. This is a somewhat technical term, and I promise you is about as technical as I will get. But these are a set of climate conditions that directly affect elements of society or ecosystems. I'm reading this definition at the bottom. Climatic impact drivers and their changes can lead to positive, negative, or inconsequential outcomes, or some mixture. But really that last thing is important because what we're saying is we have to understand the context in which this climate condition is happening to figure out if it's a good thing or a bad thing. So we all, for example, know that something like snowfall might be devastating to a crop, but we also might love skiing. So we can't say snow is good or snow is bad. We have to figure out the context and understand that. So that's one example of something, and we're looking across all different aspects to figure out what are these climate conditions. And we came up with this list of about 30 specific CIDs, climatic impact drivers, and some of them are pretty obvious, like the mean surface temperature. But if we think more broadly in this heat and cold category, we want to understand the average condition as well as extreme heat. But we also want to understand how extreme cold is changing, especially frost, because so many things happen around that particular aspect. We have other major categories, the wet and dry categories, wind and storms, snow and ice, other things like radiation and atmospheric chemistry, lots of climatic impact drivers at the coastlines, and of course in the open ocean there's many things to look at as well. So this is one way that we've tried to organize the way we think about climate information, and in every one of these we try to connect it to specific indices and metrics that are important. For example, I'll just pull out one here in extreme heat. We might not just say, is it hot out? Is it a 99th percentile heat event? We might ask, is it so hot that corn is going to start to fade and we're going to start to lose corn yields? What are those thresholds and tolerance ranges for different systems? Because that's the information we need for adaptation. So let's see. This doesn't seem to be responding. Can we advance this slide? Thank you. So, so this is how we look at just that extreme heat category in terms of observed evidence. And this is a stylized version of the world. You will notice we've taken regions of the world and fit them into these hexagons. But if you squint in your eyes, you might see North America and South America and Eurasia and Africa and Australasia out there. So these are about 50 different regions that we've assessed in multiple chapters within Working Group 1. So Linda's chapter went through these in the Atlas, and then we also did in our chapter. But what you'll see in all of the places that are red are places where we have observed trends in hot extremes, showing that there's an increase in these hot extremes in the observational period. Where you see many dots are places where we not only see that observational trend, but we connect it to human influence. We can actually detect the human signature on that increase. So you'll see that almost all parts of the world we are now observing and identifying that we are the cause, not just of that mean temperature that Linda was talking about, but even the extremes. All right, I got this now. This is looking at a different climatic impact driver. This is now looking at heavy precipitation. And you see there are many parts of the world where we have this observed increase in observed precipitation as well, and can connect it to our human influences. You'll notice that some of the places have gray, which means there's limited data. This is more reason for us to have observational networks and more scientific study in some parts of the world. That doesn't mean there's no signal there, it just means we don't yet have the evidence basis to say it with the certainty that we would like. Finally is looking at agricultural and ecological drought, which is a way of asking if there's enough moisture in the soil for living things to grow. And again, you'll see that there are strong regional patterns in terms of places where we have these brown colors indicating an increase in drought. So we see these trends in the past, and the top line is the big message here, which is that climate change is already affecting every inhabited region across the globe, with human influence contributing to many observed changes in weather and climate extremes. I've shown you just a couple, but you can imagine that whole list of climatic impact drivers. We're looking into all of those things. Now, we also take that list of climatic impact drivers out into the future. And here is a look at the bottom of this panel. This is the same list of climatic conditions at the top. But the bottom here is looking across all of the regions that we assessed. Do they tend to be moving in one direction or the other direction in our projections? So let's take the very first column there. It probably is hard to read in the back, but that says mean surface temperature. And you'll notice the purple bar goes all the way up to the top of the shaded area, which pretty much means everywhere we are assessing mean surface temperature, it is increasing. If you go a couple columns over, or 3 columns over, that's frost. And you'll see in most parts of the world, we see a decrease in frost. That makes sense, but that's what these bars are showing us. As you move across this, you'll see some of them are mixed signals, like aridity. Some places are becoming more arid. Some places are becoming a little bit more moist in the overall water cycle. That's because there are strong regional patterns in the water cycle that we are trying to follow. And if you go far enough, you might find a column that says hail. It's about in the middle, and we have almost no strong evidence about changes in hail, positive or negative. So we include that information now because we hope by the 7th assessment report or the 8th assessment report, maybe we'll be able to fill that in. But it's important to even mark in the IPCC what we are not sure about so that it can motivate more research and be honest with the program and plans that we have. I'll just lastly point out the other place where we have really strong agreement is in changes in chemistry in the atmosphere and oceans and the coastal effects of sea level rise. There's just a couple statistics. There's more than 5 different climatic impact drivers changing in every region that we assessed. More than 10 changing in 96% of regions, and more than 15 changing in 50%. That's why we're saying that multiple climatic impact drivers are projected to change in all regions of the world, and they can go further and say that the changes are more pronounced and widespread with every increment of climate change. Finally, I'm just going to show this one slide, which is to emphasize that we do not think of things just as extreme heat, but we go further and say, what are the thresholds that matter? I mentioned one for crops already. This is a threshold that was developed for human health, in particular, our ability to work outside or exercise outside. So this is the NOAA heat index, which is a combination of high temperatures and humidity. And where you see these increasing dangerous conditions are places where agricultural labor and construction work and other things that happen outside will be restricted, at least in parts of the day, which has all kinds of challenges for the future. So we want to understand how things are changing, not just in their intensity, but in their frequency, their duration, the seasonal timing, and the spatial extent. For example, where might hurricanes reach, up the eastern seaboard in the future? And then, of course, we want to get to those regional changes so we can motivate action. Thank you.
Wonderful, thank you. Let's bring Linda back. I think she's waiting. Yep. And Jesse, wonderful. Jesse, would you mind sharing some words with us as well?
Is that working?
Yes.
Okay, great. So I'm going to take you in a little bit of a different direction. I'm not part of the IPCC, or involved in the reports, maybe one day, but I'm going to talk to you about something called tipping points in the climate system, which has received a lot more attention recently in the general public and also in the most recent IPCC report. Does that work? No? Next slide. There we go. So just a quick theoretical background, and I think this is as theoretical as I'll get, but just so you understand, a tipping point is where a small change in the forcing may trigger a qualitative change in a system. So there may be change happening already, but once a system reaches a tipping point, the change might become abrupt or irreversible. So if we take this figure here as an example, this is what's called a double well potential. We have a steady state here on the left side. So a system is in this state, and there may be small, can you see my cursor, by the way?
Yeah.
Yes.
Yes.
Okay, so there may be small perturbations to the side, so small forcings of the ball to the side, but since the state is a stable state, the ball will return back to the middle. But as there's additional perturbations, additional forcings, and feedback mechanisms, the ball may eventually be able to make it over this hill and tip into a new state, so into basin B, which is not necessarily a worse state, but it's an unknown state. So if you can take sitting on a chair, for example, and you're leaning back on your chair, and you're slowly leaning back more and more, eventually you'll hit a point where you fall over, and that's a good illustration of a tipping point. So why do we care about these? One of the reasons is that there are theorized to be many tipping points within the climate system. So the climate system consists of multiple subsystems and nonlinear relationships, which give it the potential to exhibit tipping points on multiple scales, so on local scales or also on global scales. And these tipping elements, these parts of the climate system that might tip are called tipping elements. So things like dieback of coral reefs, or dieback of the Amazon forest, or collapse of ice sheets are all potential tipping points. And this idea was introduced in the IPCC report about 2 decades ago. At this time, these tipping points, they weren't called tipping points at that point, but it's what we now know as tipping points, were considered to be likely only if global warming exceeded around 5 degrees above pre-industrial levels. However, as Kristin mentioned earlier, recently we had a new paper that came out in Science about a month ago, in which we did a massive review of the tipping point literature, and we see that tipping points may occur at much lower temperatures than previously thought. We found that tipping points could already be exceeded even between 1 and 2 degrees. So for a lot of major tipping points, such as the Greenland ice sheet, we may already be in the range of where the element may tip. And if we continue on the business as usual scenario, which will take us to about 3 degrees, we may pass the threshold for 7 of these major tipping points. One of the reasons that this is so important is that a lot of these tipping points, once they're passed, are theorized that they're irreversible and we won't be able to get back to where we are. And we see in the most recent IPCC report and also in the CMIP5 and CMIP6 models that there's a lot of support that these tipping points occur. But we also have some observational evidence. So I'm going to come back to this kind of evidence-based part that this symposium is supposed to cover. So just a few examples of observational evidence that we have for tipping, or for that tipping is occurring now, or we're on the brink of tipping in some elements. The first that I want to show is for the Greenland ice sheet. So this figure here is showing the loss in ice mass, and as the ice on the Greenland ice sheet is lost, this loss of mass is accelerating and is a reinforcing mechanism. And this is important because it could lead to adding a further 7 meters of sea level rise over the next thousands of years if the whole sheet is destabilized. Another one that's talked about often is the collapse of the AMOC, which is the thermohaline, part of the thermohaline circulation of the ocean. It's a key part of the global heat and salt transport, and if it were to collapse, it could have grave impacts on the world, leading to things like cooling in the northern hemisphere, further warming in the southern hemisphere, and recent observational evidence indicates that it's weakened by about 15% in the last 150 years. And then a final example that I wanted to show was the Arctic permafrost. So as the surface layer of the permafrost is exposed, this exposes deeper soil layers to thawing and decomposition, and this is then leads to further warming, and this is a reinforcing mechanism that will lead to eventually a tipping point. And observational evidence indicates that permafrost is thawing much faster than model estimates originally showed. So these are all, it's kind of a quick rundown of a lot of the work I do with tipping points. And one of the reasons we're so interested in this is because it has it should have real gravity in policymaking, as it is kind of shows one of the worst case scenarios, and we should definitely consider the worst case scenarios when trying to make policy so that we avoid them at all costs. I think that's it. Yeah, that's my last slide.
Wonderful.
I will try and stop screen sharing. That work? No? Stop share. There we go.
Perfect.
Perfect. Wonderful. Thank you, everyone, for walking us through those examples. I think it's incredibly helpful for us to hear some of that, thinking about how you're considering all these different components. The next question I want to ask, I know, Linda, you're a member of the National Academy of Sciences panel on advancing climate modeling. Alex, you contribute to multiple efforts aimed at comparing and improving climate models. And Jesse, you're now applying climate model projections to better understanding these full climate systems and tipping points. Can you take us from these models and from some of the physical science that you just showed us and talk to me a little bit more about climate action? What role do you take in translating this information, or how does it feed into action around this? Jesse, you just left off making a comment about policy. Maybe you'd want to kick us off here.
Well, I think in general, things that we often preach a bit is that we have to take the precautionary principle. So when trying to advise policy making, we need to make sure that things that are potentially considered low likelihood but high impact events are considered and avoided at all costs. And if you think about the potential, so what I showed before, the tipping points are potentially more likely than previously thought, or may occur at lower temperatures. So it kind of puts us in a scenario that we're in an emergency scenario and we need action immediately. So just trying to push for this action and try and make the science as sound as possible so that policymakers have the correct information in hand.
Wonderful. I just heard precautionary principle. I'm looking at the students who might discuss this in classes. Is this sounding familiar? Wonderful. Alex, what would you comment?
Yeah, so we use climate information in many different ways. I'll highlight a couple of things we do in the agricultural side. For the most part, when we're working in a given region, we'll try to engage the national adaptation planning process. So our goal really is to understand what their decision-making process is, and that might involve national governments, civil society, private sector, farmers unions, farmers themselves. And we might try to find the decisions that they're making that are on climate timescales. So we're not going to come in with a climate model and tell you when to plant your seed this year. But if you're planting a new reservoir, or if you're designing a new genetic variety of seed, that's on a 10 or a 50 or 100-year time frame, depending on the decision that you're making. You need climate information. So we start to talk about how risk is changing, and we lay out different scenarios of, this is what you can control. and maybe what is controlled by the global emissions policies. So if we're working in Zimbabwe, they don't have much of an ability to change the global emissions because they just don't have many emissions to begin with, but their own agricultural systems can be made more resilient, and we can talk about how to do that. When you do those scenarios things, one of the things we sometimes discuss is what is sometimes called war games, which is not really about war as much as saying, if this happens, how will you respond? And if you respond that way, how will this other group respond? And can you play that out? And that allows us to be a little bit more proactive and start to think about, what is that challenge that's coming down the road, so that when we start to see the early evidence, kind of like when Jesse was saying, if you can see those tipping points before they actually happen, you can have that plan to dust off and put into action.
Wonderful. I'm starting to understand how powerful that can be, that information in advance. Linda, would you want to weigh in a little bit from your experience?
Yeah, and Alex has kind of set me up for some of these comments, and I just want to emphasize the importance of engaging with the stakeholders who are going to use the information, and the importance of the co-production of climate information. In other words, you don't just produce the information over on the side and kind of throw it over the transom to the stakeholders. You really need to work very closely with them to co-produce this information so that the information is both usable and useful. Now, what's important about that is that that takes more time than just creating a data set and throwing it over the transom. So it's a more intense kind of interaction. But that's really very important for this information to really be useful, let's say, for example, for adaptation. As part of that, this also involves how to make decisions under uncertainty. And this is a theme that kind of entered into the IPCC at least one, maybe 2 cycles ago, that we're never going to get rid of all the uncertainty. There's always going to be some uncertainty. And so we really need to know how to navigate this for the sake of making good decisions about adaptation. And so that, again, requires really carefully working with stakeholders, because that might require the stakeholders to also change their protocols for how they make decisions about, for example, planting or building infrastructures and so forth.
Wonderful. So let's talk about that. So engaging with stakeholders, making this decision making. This morning we heard from a lot of local folks trying to make those hard decisions for central Pennsylvania. I'm curious, when we move from global to these more regional perspectives, what type of evidence does the IPCC look for when determining a really high confidence projections for regional climate changes?
Maybe I'll kick that off. So we, as I mentioned in the last session, when we're doing an assessment, we are trying to understand the big messages and apply some kind of confidence to them so that the policymakers can figure out if this is really actionable. So one of the things we emphasized, at least in Working Group 1, was the idea of multiple lines of evidence. And I'll analogize this to if there's a murder trial going on and you have multiple eyewitnesses, you have the murder weapon, you have a videotape of the murder taking place, everything that you could possibly want. Even the guy before he died said that this is the guy who killed me, right? Like, you want all those lines of evidence to be really ironclad. What we were looking at in the IPCC to get to those highest levels of confidence was that level of, we see this from multiple angles, from multiple methods, and they're pointing us to the same message. So in particular, we would look to see if there was an observational trend in some kind of regional change, like extreme heat. Then we'd look to see if we could detect and attribute the human influence, so it's not just coincidental, but something that we can say humans are driving. Then we would look in the future projections to see if that trend is continuing or amplifying in some way. And finally, we'd make sure that all of that is grounded in a physical understanding of the dynamics or the chemistry or the processes that lead to that change. So when you can put those things together, you can get to that high level of confidence.
Nice, thank you. Any other comments from our folks? If not, I'm happy to move on. Yeah, good, wonderful.
Confirm these multiple streams of evidence, if you will, but to say that the understanding problems and how they're defined on a process level is really, really very key. It's another thing that takes more time, but we really need to establish the credibility of, particularly on a regional scale. And this, for example, in the Atlas backward, we also use different sets of projections, both in the global and the regional. And so I'd say this time around in the IPCC report, there's a much greater richness of opportunities to look at evidence.
Wonderful. I might push, Linda, with your history from 1995 all the way up to 2022 of participating in these climate change assessments. You told us a little bit this morning, which I thought was or just previously, about how the statements have been changing all the way up to indisputable. Can you expand on that and tell me about how these different working groups are being integrated across each other? This morning we sort of gave it as physical science and then impacts and then mitigation, but I'm curious if they've changed over time and how they've worked together.
Yeah, very happy to talk about that, Kristin. So this greater integration across the working groups is really a watershed moment that is really reified in the IPCC, the AR6 report. And there had been some movement towards that earlier, but it would be sort of like, sometimes we would get a little closer, then they become more separate and become more stovepiping. And I think, one of the things we learned from talking to reporters about this is reporters don't divide the problem up into nice, neat little 3 working groups. And I think it's unfortunate, quite frankly, that the IPCC didn't get this message of the importance of integration earlier. I think we would have made some greater progress in it. Because in order to really solve a problem, you have to look at the 3 working groups really together. And although there's always been synthesis reports, they haven't always done as good a job as they might have. And I'll be very interested to see if Alex has a comment on this. Okay, so the importance of integration. There's also been a change in the conception of structure as the IPCC has moved forward. And I'm going to try to quickly share my screen here. Briefly.
Wonderful.
Come back to share. Okay, now on to the next.
Got it.
Yes.
So here's an overview of on the risk assessment approach. And this is actually from the 5th assessment report. In the 6th assessment report, this overall structure is similar, except it's more elaborate. And what I want to point out here is that rather than, and I think you can see my pointer, starting with the climate up here and then moving on to the impacts, and then what we do about it in terms of mitigation, this really shows the different frameworks of this on the same playing field, that all of these aspects of the climate change problem are equally important, and they all contribute to this central concept, risk, that Alex also referred to both in the earlier session and this time around. And I think this changed structure makes a tremendous difference in terms of how the IPCC authors view their own part in the problem. So I think this is a very important shift, and I'm really very, very happy to see this. 2 other factors.
And Linda, can I just ask you to speak up a little bit more? For some reason, something glitched on our end, and you're a little quieter than you were before. So hopefully, I want to make sure everyone in the audience can hear you.
Does this help?
I think so.
A little bit better, yep.
All right, I'll just try to speak more loudly. So 2 other important things is the importance of the regional scale. That's something else that had been it was there in the earlier reports, but it wasn't fully present. And I think that partially had to do with the spatial resolution of the climate models. But I think there was also this lack of awareness in Working Group 1 of just how important having regional results was, because Working Group 1 was not well integrated with the other reports. So moving on to much more regional information, I mean, for example, from the Atlas chapter, we have fact sheets, and I think Karen Sato mentioned that also in the earlier section. We have fact sheets describing what the major climate changes are for every region of the world. Another important advancement that has, again, really come to the fore in this report, as opposed to earlier ones, is the importance of communication. And the effort, I don't have a graphic of this, but if you looked at the budgets for IPCC, how much was going into communication? In the earlier reports, it was very, very limited. And now in the IPCC, in the 6th assessment reports, the amount, I can just speak from working group 1 on this, the amount of time and effort we spent on different communication modes is just tremendous. And there's much more information for communication on the IPCC websites themselves. So those are my major take-home messages regarding the changes that we see, particularly as we came into IPCC, the AR6 report.
Wonderful. Alex, I'm wondering if, as now on the core writing team for the synthesis report, if you've got some to add there about how we're distilling these key messages and pulling these things apart. I think Linda gave us a great overview of this more integration.
Yeah. I'll try to keep it short because I know we're getting close on time. But yeah, I mean, one of the interesting things about the synthesis report is drawing all of these reports together. It's one thing for us to just copy and paste and make a stitched quilt kind of version, but what's more interesting is when we start to see patterns that overlap. So I'll just share one, which is when we're thinking about enabling and constraining conditions. We find that in many cases it's the same type of changes that make adaptation or mitigation and even sustainable development more possible. So that's things like understanding, financial flows and freeing up finance for climate investment. Inclusive governance, direct confrontation of inequalities, injustices, gender issues, things like that, technological transfer capacity, the list goes on. But these are not isolated to just agricultural sector. They're not isolated just to adaptation. They're not isolated just to a sustainable development challenge. The power is when they come together and they intertwine and make the overall action stronger.
Nice. I'm going to take that idea of communication and translating to action and put it together with a quick question. So we're saying at least 97% of scientists agree that climate change is occurring and that the greenhouse gases emitted by human activities are the primary driver. I think Linda's word of indisputable comes to mind. But when the Pew Research Center asked Americans what proportion of scientists agree, they said only 52% of Americans think that climate scientists agree that the Earth has been warming in recent years. And I think it's interesting to consider this discrepancy between reality and perception. I'm curious if you can talk to me a little bit about what role you think the IPCC might play in bridging that divide there.
Yeah, if I could, Kristin, I'd like to lead off on that because in my role in Working Group 2 as the review editor for the chapter on North America, very interesting aspect of this chapter is that it actually took on the issue of the problem of misinformation and politicization of climate change, and particularly signaled that the United States, unfortunately, within North America, has the biggest problem with this. And they documented through literature, so this isn't just a general opinion of the authors, they really documented that this polarization and this conflict about is climate change even happening, which, from those of us working on the IPCC is really hard to grasp, but that really has limited climate action, and it has delayed urgent adaptation planning and implementation. And I think, I'm not positive, I haven't read all of Working Group 2, I think it may be the only regional chapter that actually documents that very clearly. So And that's certainly truer of the United States than the other countries making up North America, Canada, and Mexico. If I could also just very briefly share my screen for the final time, come back to screen. This is not exactly on the same point, but it's close enough. This has to do with the relationship, that issue of relevance versus prescriptive policy statements. And I think something very interesting happened this time around at the Conference of the Parties, number 26, that occurred in Glasgow last November. And I was there along with many colleagues. And for the first time, the authors of the IPCC from the Working Group 1 report sent a letter to the negotiators at COP26 urging them to fully acknowledge the most recent climate assessment. Now, I would maintain that that still keeps us within policy relevant, but not policy prescriptive. And I won't read this whole quote from the letter, but we know that the 2 degrees C and the 1.5 degrees C thresholds are very scientifically justifiable. There's no question about that. So really what we were doing in that letter was just really emphasizing to the negotiators, hey everyone, this is really urgent now on this whole other level, such that the IPCC authors felt it was important to stress that urgency.
Nice. Thank you very much. In the interest of time, I'm seeing some questions come in from our online community. I want to make sure we've got time for students to formulate some really exciting questions in our audience. I'm going to start by kicking one off from online. So Xenia Galan asked us, given the importance of integration across disciplines and co-creation of knowledge with stakeholders, how does the structure within academia impede or potentially advance this? Anyone interested in tackling that question?
I'll take a little stab here. So yeah, I mean, it's certainly true that interacting with stakeholders, engaging with stakeholders, we like to use the word sustained engagement because it's not enough to just show up and knock on a door, have a nice conversation, walk away. You need to make personal relationships. You need to follow up. You have to be tenacious in terms of interactions. That takes time, and if you're a professor trying to get a tenure and you're judged on papers alone or reviews from your class, you don't have time for that kind of thing. So in many ways, climate change is forcing people out of the standard disciplines, out of the idea that academics are judged only by their scientific output, by standard metrics like paper citations and H indices and things like that. And actually, I think there's increasing conversation about the impact of the overall scientific output. And part of that is building up capacity so that the stakeholders can use the information. And there's, of course, very interesting research questions on how that's all done, but not everybody can be theoretical in that. It's really, in action. And there are increasingly schools and disciplinary department or interdisciplinary departments that are making space for that kind of research. And we're seeing the students flood into those areas because it's attractive, it's interesting, and it's kind of the future is in the interesting spaces between the traditional disciplines.
Can I morph the question a little bit before someone jumps in? We have a whole audience of students here in front of us and online. Alex, you made a great point to point out that they are flooding in those directions. And I think about Dickinson as being community engaged, interdisciplinary, and sustainability science. What advice would you give to students who want to engage in this work moving forward? What should their training look like? Yeah, Jesse.
I think the interdisciplinary kind of whole system view is important, but I also think students that are really want to engage in this and move forward is you also need to have subject-specific knowledge. I think it's key. Really, as Linda said before, really understanding the models, understanding the processes is necessary. but like a lot of the work I do with a systems view, so to try and understand the individual processes while also looking at kind of the whole system and the kind of feedback, synergies, trade-offs, as Alex said, like the IPCC synthesis report. The goal is to kind of look at what the enabling and constraining conditions are across the system. But in order to be able to do this, you really need to have some people that are there with the subject-specific knowledge.
Yeah, if I could just add, I realize we don't want to stay on this too long, but I think there really is a tension in academia about this. I was just at a meeting at the University of Wisconsin on the board of visitors of the Nelson Institute that tries to be very integrated. But universities are also supposed to be bastions of academic freedom. And I think that really creates a tension in terms of having the depth of interdisciplinary research that is needed, let's say, to solve or to contribute to the solutions to climate change, versus researchers being able to do their own thing. And I think this is a non-trivial problem that needs to be grappled with very seriously, so that there can be academic freedom, but also have the type of interdisciplinarity that will contribute to solutions to, for example, the climate change problem.
Nice. Having said that, let's look to some questions in the audience. Do we have folks with questions?
One up there, I see.
Hi, can you hear me? This question is to Alex, but Jesse and Linda, feel free to hop on. You mentioned Zimbabwe earlier, but one of the major criticisms of COP26 and climate conversations alike is that there's a lack in representation, not like in presence and existence, but more like in messaging, process, reasoning, and solution. So my question is, how is the conversation being adjusted to serve a more inclusive purpose to make applicable solutions everywhere?
Yeah, so we addressed this a little bit in the previous session. The IPCC itself has taken dramatic and concrete steps to bring in more people from different backgrounds, from different countries, not just academics, but people from government research labs, private sector, and other things like that. And a much stronger north-south balance and other things like that coming into play. The dynamics of the international negotiations are really fascinating because there's clearly geopolitical undercurrents to everything. Certainly the United States has a bigger seat at the table than some other countries, but I'll also point out that I now know the delegate from St. Kitts and Nevis, which is a small island nation in the Caribbean, because that delegate knows climate and she would stand up and ask good questions, and that small country also has an outsized seat at the table because of the engagement of those partners. So it's interesting that the UN process actually gives a microphone to countries of all size, but you need that support, and you have to have an inclusive process so that it's heard, not just articulated.
Yeah, I'd like to add a comment to that because I've been to a number of the COPs and was at COP26, and I'm sending people to COP27 taking place next month. One of the issues that gives me a little hope about this is the issue of damage and who pays for the damage. And it's well known that the countries that have produced most of the greenhouse gases are less vulnerable, for the most part, to a lot of the damage. For example, let's take Typhoon Haiyan, which affected the Philippines very strongly. I think the issue of damage and who pays for it is becoming a stronger and stronger issue. And I think it was very clear from COP26 that that issue will be very much front and center at COP27. And yeah, quite frankly, a number of the well-developed countries try to shy away from that because they don't want to end up having to be responsible for the damage. But I think, quite frankly, it's going to be very difficult for the developed world to keep avoiding that. And so I would look to COP27 to see that issue become more front and center. And I think that will certainly help some of the issues that the questioner asked about.
Josh, we've got some more on this side.
Just one more thing on that point. There's been some really concrete frameworks on how to deal with loss and damage and who covers it. The Prime Minister Mia Mottley from Barbados and her economic minister really put together a solid framework me and some other colleagues have been working on as well, and we're also trying to examine this and how you cover it. And yeah, it's just a very important thing that definitely needs more attention and also needs more commitment from the so-called developed nations.
Agreed.
Josh, did you want to make your way around? There's one up here in the front. Go ahead and keep going.
Thanks so much. So I wanted to ask a question that I often hear from scientists, where the last one of which Jesse Abrams just said, where he said, this data should have impact in policy making. And I've heard this for decades and decades, right? So as a scientist, I have to revisit that assumption. And why is it that we keep saying should have effect on policy and it doesn't? So I'm asking us to rethink how society's changes, especially at a global level, and how the human brain works, in that there's an assumption under there that humans can change policy based upon science and facts. And that's not what the psychology tells us, and that's not also how our government works, right? And I think this ties also into this global impact and what we think of at economics, right? If we had implemented something as like a system change, such as carbon fee and dividend border correction a few decades ago, we wouldn't be talking so much about having to pay for impact, for example, right? We know that there's more and more climate impact that the rich worlds have caused on the poor world, right? And we keep talking about this, and yet we can't change our energy system quickly enough to even begin to address that. And so, this also comes into what Dr. Kim was saying this morning about, I think it was him, but several other people saying how politicians think short term, and we're trying to put a long-term problem in front of them. So I think trying to get at the complexity that goes well beyond scientific facts, right? We've had IPCC reports that have been very strong for at least 2 decades on the human contribution to climate change. Right, so I'm just asking that, do we need to start thinking about our assumptions and go beyond, trying to think that facts is what's going to change policy?
Yeah. So I'll be happy to let my panelists respond, but I'm also going to say, stay tuned. We have more folks coming, and we're talking about a whole lot and we're digging into some of these things more on multiple days. But I'd be happy to have our panelists say something.
I saw Jesse's hand. Go ahead, Jesse.
Yeah, I can just say something to some work that we're trying to do, where we're trying to identify these larger systematic changes. So it's something that my institute director, it's his little brainchild, called positive tipping points, where we try and take the tipping point framework and use it to identify tipping points in socioeconomic systems, but in a positive sense. So where we're currently in a negative state, that undesirable state, we're trying to identify mechanisms or systems that need potentially small changes, small enabling changes that allow the system to tip in the direction that we want. And because we're in such kind of an existential crisis, we need to limit ourselves to 1.5 degrees if possible. Hope 2 if that's not possible. We need to find these kind of inflection points that will lead to kind of rapid decarbonization, accelerating change. So it's something we're working on. It's also one of our ways to try and stay positive and build hope around the whole thing. So yeah, that's one way that we're kind of approaching this.
Yeah, let me chime in just briefly on this. I think there have been it's kind of similar to what Jesse is saying, watershed moments. For example, the IPCC authors writing that letter to the negotiators was really a very different way of interacting with the negotiators. And I'm not saying, I think the science is important, but yes, obviously there needs to be more than the science. But I think if you looked at what will happen at COP27, I think there's just more and more pressure being put on the developed world to, for example, take responsibility for the greenhouse gases. So I think not only will you hear more about this in the other parts of this symposium, but I think if we look at COP27 for next month, pay attention to what happens there. And I think some interesting things will happen. I certainly hope so.
And stay tuned today. Unfortunately, we're out of time with this panel. I want to take a minute to point out all these moments of hope that we did hear about, this stronger certainty in the science. We heard about integrating with action. We heard about these disciplines that might have stayed unique are now merging. Please take a minute to thank our panelists today with me.
So thank you both to our audience here and the live stream audience. Our next session is going to begin at 3 o'clock, and that session is Pathways to Net Zero Carbon. So I hope many of you will come back and join us for that. And once again, thank you.